Assalamualaikum warahmatullahi wabarakatuh. I'm Tiara Anissa Danella. My student ID is 163018. I will do a presentation about landslide hydrology. First is hydrology and landslide. Hydrology is a science that encompasses the occurrence, distribution, movement, and properties of the waters of the earth and their relationship with the environment within each phase of the hydraulic cycle. The water cycle, or hydraulic cycle, is a continuous process by which water is purified by evaporation and transported through the atmosphere and back to the land and ocean. All of the physical, chemical, and biological processes involving water as it travels its various paths in the atmosphere. Next is landslide. Landslide is a movement of rock, earth, or debris of the water-sloped section of land. It can be caused by rain, earthquake, volcanoes, and etc. Mass wasting is any downward movement in which the Earth's surface is worn away, including rock falls and the flow of shore deposits called alluvium. The landslide material itself containing the rock, soil, vegetation, water, or some combination of all of it. Next is landslide impact. Near populated areas, landslides present major hazard to people and property. Landslide cause an estimated 25 to 50 deaths and 3.5 billion US dollar damage per year in United States. Next is the causes of landslide. So what the causes of landslide? There are three major causes of landslide. It is geology, morphology, and human activity. For the geology, it refers to characteristics of the material itself, and for the human activity, refers to agriculture and construction impact. We must focus on morphology, that is, refers to structure of the land, and for example, vegetation holds soil in place. So if the slope lost the vegetation, the land will slide away. It called erosion or weakening of earth due to water. Rainfall trigger landslides. The hydrology in and around a landslide area is a key to pore pressure buildup in the soil skeleton, which reduces shear strength due to the buoyancy force exerted by water in saturated soil and to soil suction in unsaturated soil. Extraordinary precipitation can cause landslide, or at the same time, the vast majority of slopes do not fail. The landslide hydrology consists of three things. It is pore, hill slope, and catchment. Next is landslide hydrology. One is most landslides and debris flows worldwide occur during or following periods of rainfall. Many of these have been associated with major disaster, causing extensive property damage and loss of life. Second is give concerns about the effects of climate change on the precipitation regime. In the future, some mountainous areas may likely experience more landslide with a faster response to rainfall. However, most such projections are weakly based and remain untested. Third is subsurface hydrology is usually the main triggering mechanism of these landslides and associated debris flows. And fourth is while the effects of hill slope hydrology and runoff generation have been thoroughly studied, much less attention has been paid to these effects on landslide and debris flow initiation. Recent syntheses demonstrate that it is no longer appropriate to view the subsurface as a static media which facilitates the transit of subsurface water, rather a variety of factors affecting the dynamics of subsurface hydrology need to be considered. Both the infiltration of rainwater and snowmelt and bedrock exfiltration provide the local trigger of these landslides, while drainage and evapotranspiration tend to stabilize hill slope by rerouting and removing subsurface water. Next is subsurface hydrology is strongly affected by preferential flow within the soil, substrate topography, and exfiltration from fractures in bedrock. The overall regolith moisture regime and recharge rates are influenced by evapotranspiration, soil development processes, soil water groundwater interactions and landform aspect and shape. The dynamic behavior amongst these interacting hydroecogeomorphic components evolve across spatial and temporal domains, creating the conditions for landslide initiation. The resulting hydrologic dynamics that includes changes in soil moisture and pore water pressure remain an important focal area of investigation and are addressed in the spatial issues along with hydrometeorological threshold for landslide assessment and early modeling. Next is landslide hydrology case in Town, Utah, United States in 1983. The tragedy starting with heavy rain and melting snow hit the town, and it causes landslide that carry the mass of 305 meters wide, 61 meters thick, and 1.6 kilometers long. And it slid across the Spanish Fork River, severing railroad and highway lines. And the coast lies landslide in U.S. history, causing about 400 million US dollar damage, destroying Thistle, which remains as an evacuated ghost town. And this is the end of my presentation. Sorry if I make any mistake, and Assalamualaikum warahmatullahi wabarakatuh.